Okay, so for properties of equality, these are the things that we've already reviewed. Okay, so we have if A equals B, and if I add something to that, if I do A plus C, then to keep it equal, what do I do to the other side? If I add C on one side, what do I do to the other side? You add that to the, so this B stays the same, but we add C to the other side. The idea is what we do on one side, we do to the, and that you have no idea how big of an expression that is. Right now, we're just dealing with multiplying, dividing, adding, and subtracting. Those of you who are going into the Math 51 direction, that intermediate algebra direction, not all of you have to, but if you do, we kick this up quite a bit. It is really cool stuff. You can do exponents, you can root, you can do some pretty crazy stuff with equations, as long as what you do to one side, you do to the, and it keeps it equal. So that's kind of cool. But we can do that with adding. We can do that with subtracting. So if I have A minus C, then this side would be what? And if we do it to both sides, it stays equal. I can also do it with multiplying. So if I have A times C, then I would have B times, and yeah, normally we put that in alphabetical order, so you could do CB or BC, either way is fine. And if A equals B, then A over C would equal. So we will use this with equations. We will use adding, subtracting, multiplying, and dividing to solve equations. And I have some quick examples here on the side. Okay, so for instance, we have some number minus 6 equals 10. That does not hurt my feelings if you know the answer to that. That's a good thing, right? You're like, yeah, I know that 16 minus 6 is 10, right? But the idea is the process is going to work now when things are easy, and you're going to see some examples today where they're harder, and the process still works the same. So how do I get that x? How do I isolate that x by itself here? To undo the subtracting, and if I add it to one side of the equation, then there's that right side, right? If I add it to one side, then I have to add it to the, and then we've justified algebraically that x equals 16. And I could check that by doing 16 minus 6, and it would give me 10. Is that okay so far? So we can undo subtracting with adding. On the second example, I have plus 6. How will I undo the adding? To get that x by itself, we would subtract to undo the adding if I do it to one side. On the left side, I'd be left with what? These 6 minus 6, they cancel out. They leave me with 0. Don't just slash them and go, oh, they just canceled. Think about that. It's positive 6 and negative 6. That was our last section on real numbers. Those cancel each other out, leaving us with nothing, right? And so if there's nothing there, I'm left with only the x on the one side. And on the right side, you said negative 4. And I could check that. Is negative 4 plus 6 going to give me a 2? Opposite signs, they would cancel, leaving me with more positives, 2 more positives. So there should still be some logic behind it, but let's agree, that one would be a little harder to do quick and mentally in our mind. So we need to know the processes that go here, right? I can use adding, I can use subtracting. What do we do on the next one? See, since x is being divided, we will use multiplication to cancel that out. So since we have x divided by 6, what would I do to both sides of the equation? Multiply by what? By the, there you go. So why? Well, this, now I have a 6 on the top of the fraction, a 6 on the bottom of the fraction. What do they do? Yeah, and they don't just disappear. You say, what is 6 divided by 6? 1, and that's what we wanted, was 1x. Every single one of these answers is 1x, 1x, 1. That's our goal, right? And you can write the 1x. It doesn't hurt my feelings, but we don't need to, okay? So we would now just write that as x is equal to 12 times 6. And we could check that. Is 72 divided by 6, 12, okay? And then last here, the x is being what? See, 6x, there's an implied multiplication there. And to undo the multiplication, and here's where I get a common mistake. 2 divided by 6 is not 3. I could check that at the beginning. Is 6 times 3 going to give me 2? That makes no sense anymore, right? You're like, but the 2 and the 6, 2 goes into 6 3 times. Awesome, that's not what we're doing though. We're dividing the 2 by the 6, not the 6 by the 2. So our answer this time will be a fraction or a decimal, and we simplify that fraction. So 2 and 6 are both divisible by. So yes, the 6 becomes a 3, but what happens to the 2 on the top? 2 divided by 2? That would be our answer. Is it right? See, and you're like, I don't know, that one's a little scary. We've done fractions. Could you check if that one's right? 6 times x, 6 times 1/3 should equal. And we have technology. I'm not trying to make you do all this from scratch. 6 times 1/3 is 2. Any questions, concerns on this before we continue? Like I said, this should all be a review. We're going to kick it up a notch with some 2 variable. We've discussed this before. Did anyone need that right now before it goes away? Doing all right? I can wait. Want me to wait? Okay. So let's do some examples. I don't know why that was funny, but yeah, you're welcome. How are we going to get that x by itself on our first example? See, that x is being what? What's messing with the x? Which number? This whole mess. My problem is it's being added by negative 13. I'm not going to use subtraction to do that. There's a way of justifying why we would use subtraction, but that if I try to do a minus 13, are those 13s going to cancel? Negative 13 minus 13, that doesn't work, does it? How would we cancel a negative 13? So we would use addition to solve this. If that bothers you, another way of thinking about it, I don't really like this, but this is a way of thinking about it, is that we, instead of adding a negative 13, we subtracted a negative 13. That's weird. But what does subtracting a negative mean? It's just adding. So a couple ways of thinking about it. But don't check out your brain. If you put a minus 13 there, that should stop you. And you should check and go, ooh, negative 13 didn't cancel. And that's our goal, is to cancel everything out, leave us with the x. So what cancels with a negative 13? It's a positive 13. If I do it to one side, so that now x is equal to, could you check that? Is 15 plus negative 13, plus negative 13, does that give us 2? And if it does, then we found the answer. What about the example 2? What's happening to the x? It's being what? So this one's being subtracted, right? Notice, why didn't I highlight the negative 5? Is that negative 5 doing anything to the x? Right? It's on the other side. Focus on what's with the x. That's what we're undoing. Just, you're like, well, it's on the left side. I don't care. We're getting the x by itself, and right now the x is on the right side. Okay? So how would we undo subtracting? So the rules don't change just because the numbers get more complicated looking. Just like we undid this negative with a positive, we undo the subtracting with adding what? If I do it to one side, don't just cross those out. Would negative 3/4 and positive 3/4 cancel out? See, stop and think about it, that those would make 0, wouldn't they? So I would now have the x by itself. On the left side, negative 5 plus 3/4. Now mine is set right now to give it to me as this. Oh, yeah, well, did I do that right? Yeah. Mine is set right now to give it to me as a decimal, but I can change it to a fraction. I know you guys have different calculators that do that. So I'm okay with negative 17/4. Also understand that they will want negative 4 1/4. That's a skill that we still need to have. You need to be able to turn that back into a mixed number so that x is equal to negative 4 1/4. Any questions on that? And yeah, there will be times where we want decimals, but generally they'll want decimals when they give you decimals.
They'll specify.
And they'll specify, yeah. Example 3. What's happening to x? So how would you undo adding? You can do adding with subtracting. That's an inverse operation. If I do it to one side, the idea is that keeps that balanced in the equation by doing the same thing to both sides. They stay equal. So does positive and negative 300 cancel out? Those all 0. I'm left with x is equal to. Could you check it? In fact, I could have checked the other one. I should have done that too. But yeah, you can plug these in and it should be the solution. Okay? How would you do x plus 3 1/8? Minus the what? Now here's my problem. I know that's going to zero out. I know I'm going to have x equals. But I can't just do 5 minus 3 1/8. But I remember I told you when we did fractions a long time ago, we need to know how to turn those mixed numbers into fractions, improper fractions specifically, right? The whole multiply and add. Because in my calculator, I can't do 5 minus 3 1/8. I can, it's just more work than it's worth. But if I multiply and add, this is really 5 minus 24 plus 1. 5 minus 25 over 8. Are you ready for this? Are you already done it? You're just waiting for me. 5 minus 25 over 8 as a fraction. I gotta stop doing that. As a fraction. (15/8). Or 1 and what? Example 5. I have x being what? Divided by? So, right, which of those two is happening to the x? The dividing by 3. Don't focus on the other number. Focus on what's with the x. That's what we're trying to undo. So to undo the division, we multiply both sides by. Here's where I'll have people look at this and go, you know, some number divided by 3 is 270. Is that number 90? They'll just divide the 270 by 3 and go, it's 90. Does that make any sense? 90 divided by 3 isn't 270, so be careful. I'm okay with logic, but check your answers. So when I multiply both sides by 3, these 3's cancel. They don't just magically cancel. 3 over 3 is 1x is equal to, what is 270 times 3? And I could check that. Is 810 divided by 3 270? And if it is, then I didn't mess up. And that's what I love, especially about these linear equations, is, you know, a lot of times when we're simplifying things, like, I hope I did it right, I hope I didn't make a mistake, I hope I didn't. Well, every single one of these answers you can freaking check. You can plug them in. And so I encourage you to do that. And some are going to be easier than others to do that with, but you should be very confident on your next test on the linear equations because you can actually take those answers and check them. Now, am I doing that on every homework question? No. I'm plugging it in and it tells me if it's right or wrong. And I go, oops, I made a mistake, let me fix it, right? But when I come to the test, I'm checking these answers. How would you solve example 6? Right? Which of those two numbers is happening to the x? So to undo the dividing, we by. So the process doesn't change just because the numbers get more complicated. What is 1.2 times 3.9? I heard 4.68. Is that correct? Could I check it? If it's right, 4.68 divided by 1.2 should be 4.68 divided by 1.2 should equal 3 point. Is it right? Big old smiley face. I don't have to worry about whether I got this one right or wrong on the test. And last but not least here, x is being what? What's the M word? So here's what I see a lot of people do. Is that correct? That is utter freaking nonsense. Why? Does subtraction undo multiplication? That makes no sense, does it? That's somebody that's just doing math. I don't know, I just did it. No, it doesn't work that way. We shouldn't just be doing anything. This should all make sense. We don't undo multiplying with subtraction. We undo multiplying with what? So what you do is you divide both sides. First of all, if I put a minus 5 there, those won't even combine. They're not like terms. Okay? So to undo the multiplying, we divide by 5. And if I do it to one side, do it to the... Do not divide by the x. We're not trying to make the x go away. We're just dividing by the number that's being multiplied by. So here we go. 5 divided by 5. Don't just cancel them. Do they cancel? Stop and think about it. Does 5 divided by 5 cancel? 5 divided by 5 is? Which is what we wanted, was 1x. Or just x. Either way. Equals? What is negative 40 divided by 5? I would be fine with either of these answers. Okay? The second one is generally the way we write it. We don't write the 1x, but there's an implied 1 there. That's fine. Okay? And you could check it. Is 5 times negative 8 make negative 40? Hey, we're doing pretty good. Last but not least, what's happening to the x? By? Does this make any sense? Somebody's like, yep, that's exactly what I would have done. Do we undo multiplying by adding? It's utter nonsense. Those can't even combine. They're not like terms. We undo multiplying by what? By dividing it by what? Not just the number, the negative. See, if it's being multiplied by a positive, we divide it by a positive. If it's being multiplied by a negative, we divide it by the negative. On the left side, what is negative 2.4 divided by negative 0.6? Should be positive is equal to a negative divided by negative is positive, and that would make 1x. Could you check it? Right? What is negative 0.6 times 4? Is it? Then see how we can check these. So please be careful on this. Okay? All of this should have been reviewed. We've had notes on this before. Now we're going to kick it up to the 2 variable. We've had notes on this before. But we are going through this kind of fast. So if you need me to slow down, stop, let me know. I can do that. But otherwise, I'm going to keep going. Are we okay? All right. Total BN. What if there's multiple steps? Well, I just put this into basically two things you need to do. If I'm going to solve it, I'm going to use inverse operations, but I cannot do it unless I have a single variable. I need 1x. And I mean, it could be 1x being multiplied by 6. It could be being added. But I just need there to only be 1x in the equation. You're going to see here very soon that we're going to have multiple x's. So what do? Simplify. If they're on the same side, we'll combine them. If they're not, we'll isolate by getting them on the same side. But before I do any of that, I will distribute. So we will have some distributing. That's part of the simplifying process. Then we'll combine like terms. We'll isolate the variable on one side. And then after that, we will have our inverse operations. And the way I explained inverse operations is I just said PEMDAS backwards. The way I formalize that is in 2 steps. The first one you guys already know. We undo adding with, subtracting, multiplying with, That's the idea. You know that it is the opposite operation. That's what people have no problem with. They're like, yeah, I got that. What people forget is what order to do it in. You do the opposite operation in the opposite order. Hence, PEMDAS backwards. You start by undoing the adding and subtracting. Then you undo multiplying and dividing. Then you undo exponents. Then you undo. And we're not going to get to all that yet. But the idea is that it's this idea of inverse operations may seem more complicated now, but it will last you. Okay? And I know it's good because, first of all, it's the way I was taught, so it must be right. No, that's not it. It's the way I find the most success with students? Sure. It may be different than what you've seen. I get it. But I'll tell you right now, when I do teach pre-calculus, there is a section in pre-calculus where they teach solving equations, and this is what they tell them to do. Do the opposite steps in the opposite order. PEMDAS backwards. If it's good for, right, Algebra 1, good for Algebra 2, it's good for freaking pre-calculus. This will last you. This is not something that it's going to work today, but when it gets more complicated, it's not going to work anymore. If you can understand the equations the way I'm explaining them here, you're going to have basically a tool set to take you through any linear equation, okay? Or any equation we can solve with inverse operations, at least. So I look at this equation. What's happening to x? I see two things. Everyone's scared now. Multiplying by 3, I heard, and so if I'm thinking PEMDAS backwards, I start by going, is there any adding and subtracting? How do I undo that adding? You do not want to divide all this by 3. Mathematically, I can. It'd be a mess. It's not worth it. So it's easier just to undo the adding by subtracting. And if I do it to one side, what is left on the left side is equal to 5 minus 2. I strongly suggest that you do these lines, especially as things get more complicated. I will have people do like minus 2 and minus 2 on the same side. That scares me. Because they're like, no, you do to one side, you do the other. But then they put the same thing on one side. That's not going to keep it balanced.
You mean the other side of the equal sign?
Yes, the equation or the equal sign is what keeps the balance. So we do it to both sides of the equation or the equal sign. Good call. Am I done? No, because going up, is there any multiplying and dividing? We will undo the multiplying by so that x equals. Is it right? Could I check it? 3 times 1 plus 2. I mean, literally, 3 times 1 plus 2 should be, I feel pretty good about that, right? Not going to do this for every single one, but if there's one that you're like, I don't believe it, let's check it, okay? And some of them are going to be harder to check, so you may balance whether it's worth it to check some of them, but some of these easier ones, feel free, okay? Next one, example 2. What's happening to the x? Subtracted, and now be careful, that 4 has nothing to do with the x, does it? Don't fall for that. The x is on the right side, so we're focusing on the numbers that are over there on the right side. PEMDAS backwards, how do I undo? Adding or subtracting? Undo subtracting by adding, I heard. What is negative 4 plus 1? You don't have to have all that memorized. You can use your technology, can't you? Okay? I mean, there should be some logic behind that. They cancel and all that, but. Now we have two options, and I'll take your favorite. I know to multiply by the reciprocal. That's a rule I was taught that always made sense to me. How would you approach it? Because there's two ways. And in my old notes, we went through both ways. How would you do it? So what you're doing is you're clearing out this fraction by multiplying by that denominator, basically. You're like, man, this fraction isn't making this any easier. What if I multiplied both sides by 3? Could I do that? Right? On the left side, I would have negative. On the right side, I'm going to multiply the numbers. What is 5 times 3 divided by 3? Well, the 3's are going to cancel out. 15 divided by 3 is just... So you basically have undone the fraction. Then you would undo the multiplying by what? We must have made a mistake, right? The answer can't be complicated. You don't think numbers like this show up in real life, right? So this is our answer, negative 9/5 or negative 1 4/5. I'm going to be completely honest with you. In this situation, I'd prefer the negative 9/5. Logically, that number doesn't make as much sense, but algebraically, which is what we're doing right now, we're dealing with algebra, that improper fraction is easier to deal with. So a lot of the times, we're going to leave these answers as improper fractions. If it's a story problem, we'd go back and go, yeah, it's really negative 1 4/5. That makes more sense. But algebraically, negative 9/5 is a better answer. It's easier to work with. Both are equal, but they have pros and cons. Okay? So be comfortable with both. Just for fun and giggles, let's check it. 5/3 times x, 5/3 times negative 9/5 minus 1. Wow. 5/3 times negative 5. Let me do this right. So control divide for mine. 5/3 times, what was our answer? Negative 9/5, is that right? And then it was plus 1 or minus 1? Minus 1? What was it supposed to equal? Hopefully negative 4. Is it right? It gets harder to check it, but it's still approachable. We can still do that. Is that okay? All right. What's the issue with question 3? Why can't I say what's happening to x? There's 2 x's, that's a problem, right? I can't just say what's happening to x when there's 2 of them. It's creepy, it's weird, I can't do that. But guess what? Those x's are on the same, and if they're on the same side, then we can what? Combine like terms. They're on the same side. I literally can just add those. What is 4x plus 5x? It is not 9x squared. That's x times x where we get x squared. When we add x's to x's, we get x's. Okay? What else do I need to bring down on the left side? Is equal to. We now have something that we can solve. Now that there's a single x, we can undo what's happening to that x. PEMDAS backwards says, do you see any adding and subtracting? You see subtracting, right? How do I undo that subtracting? Do it to one side, do it to the... What's left on the left side? On the right side? I undo the multiplying by. Not subtracting. I will come across to kick you in the teeth. Don't do it, right? We don't undo multiplying by subtracting. It's utter nonsense. We undo multiplying by so that x is equal to. I'd prefer that answer unless it's a word question, right? If this is how far you're walking, you're going to walk up to somebody and go, yeah, you're going to walk 10/9 of a mile. Thanks, that's really helpful, right? You'd be like, no, 1/9 or 1.11. You know, that's a more logical approach. Algebraically, the first answer is easier to work with. Logically, the second one is. How is example 4 different from example 3? Because I see 2 x's. So that is going to make 9x. Don't do it. It's a trap. I got a Star Wars quote here, right? Don't do it. They're not on the same side. You cannot combine them. So we are going to isolate the variable. We're going to get the variable on one side. I encouraged you to focus on the lesser of the x's. I see a 4x and a 5x. Which of those is lesser? I know it's not less. It's a proper word. Get over it. The 4 is smaller, isn't it? So how would I move that? Yeah, it's a 4. Sorry, my handwriting sucks. That's a 4x. So we undo the 4x by subtract. Can I subtract that away? Can I just subtract the 4x away because it feels good? I kind of can with equations. As long as what we do to one side, that's totally allowed. Did it fix the issue we had? Did it get rid of the other x? That's okay then, isn't it? What's left on the left side? What's left on the right side?
So we got rid of that completely?
Well, it got rid of the x on the left side. Because what's 4 minus 4? 0. That sucker's gone. Yes. And now we don't have a two-step equation. Now x is only being, looking for somebody to mouth, added by 9. Okay, now undo the adding. We so that x is equal to and I'm not messing with this. If you want to put the x at the beginning, that doesn't hurt my feelings. Again, not really necessary, but either way. So we have two different issues we have to deal with now. If the x's are on the same side, combine like terms. It's part of that simplifying step. If they're on different sides, we isolate it. We will either use adding or subtracting to move the x to the other side. Okay? In fact, maybe I'll add that. Let me see. Get the variable on one side, and we use either adding or subtracting. Okay? So using that adding or subtracting, we're going to move the variable to one side. Okay? What did I do on example 5? Yeah, because there's a single x, but there's a whole mess going on with it, right? What's happening to x? Well, it's in this group where two steps are going on, then it's being multiplied, then it's being added. You could run this whole thing through inverse operations, but it's easier just to clean it up, to simplify by, I heard the D word, distribute that sucker. What is 3 times 2x? What is 3 times minus 6? Am I done simplifying? I'm done distributing, but it also said to me combining like terms. Are there any like terms? The negative 18 and the negative 10? No, don't touch that. It's on the other side. Okay? Keep it all on the same side. So same side we can combine. What is negative 18 plus 1? Bring down the... Is that good? Now, see, that was all what I lump under step 1. That's that simplify step. Distributing, combining like terms, isolating the variable. Now we're ready for step 2. Now that there's a single x, inverse operation says, what do I do first? Undo the subtracting by. If I do it to one side, what is negative 10 plus 17? How do I undo the multiplying? So I'm okay with 7/6 or 1 1/6. Could I check that answer? Like I said, depending on your calculator, that's either easier or harder for you, but you could. I could do 3 times 2 times 7, 6 minus 6 plus 1. We could do that, and it should equal negative 10. So you literally just take this answer right here and stick that in place of the x, and it should equal negative 10. Example 6. First step. What is negative 2 times x? What is negative 2 times 1? What do I need to do with the 3x minus 6? Yeah, nothing we can do with it. I heard bring it down is a great answer. Are we done simplifying? What else can we simplify? See, there are no like terms to combine, but do we need to get that variable on one side, isolate that variable, right? Which of those two x's is less? Negative 2 is less than positive 3. Even if it was a negative 4, the negative is always less than a positive, right? You can move the 3x by subtracting it over, but I would argue it's easier to move a negative 2x. It's easier to move the negative and deal with the positives. I have a lot of people that like to always keep the x on the left side. It's not wrong. It's just in this situation it'd be harder because you're having to keep track of more negatives. Your choice. So I would undo the negative 2x by what? We're adding it over. And if I do it to one side, what's left on the left side? On the right side? Now we're ready for step 2. Undo the subtracting by. What is negative 2 plus 6? Undo the multiplying by. Thank you for not saying subtracting. Somebody did. Man. So 4 over 5. You have technology. Put that in your calculator. Hopefully you know it can't be simplified. That is our answer. But if you're not sure, stick that in your calculator. It should be able to simplify. What are we going to do with example 7? Besides run away in fear. What's so terrifying about example 7? Not only is there a fraction, which we dealt with one earlier, right? But there's 2 fractions. So I'm going to argue the scariest thing about 7 is this 4 and this 8. If there was only some skill that somebody had taught you where we could clear fractions. One might even say bust a fraction. It sounds so stupid. I know. Not bust a move. That's different. I'm old. Bust a hip. Thanks. Yeah, you're laughing at me. Think about it this way. You got the idea. Not that I'm going to give them a common denominator. That's actually the way I was taught, and I wish somebody would have taught me this. Know what the common denominator is. It's a 4 and an 8. They could both become a 8. The least common denominator is 8. But I don't want to give them a common denominator. I want to get rid of them, right? So both of those denominators are dividing. Can you see that? How would we undo division? What happens if I was to multiply everything by 8? It's like the Oprah effect. This gets an 8, and this gets an 8, and this. Every term gets an 8, right? Or Oprah's old now, so the Ellen effect or whatever. You get a car, and you get a car, and you get a car. Yep, exactly. But there's a whole new generation that are like, oh, who? That's all right. Yeah.
So really, you distribute that?
It to everything. Technically, we're doing it to both sides. So I kind of was sloppy with that, but
Is there a better way?
no. If you don't like what I just wrote there, another way of writing it would have been like this. And then this all times 8. So the 8 is distributing to both sides. Okay? And once again, to both terms. So that's okay. You have technology. What is 8 times 3/4? Well, it divides in. What's 2 times 3? Make sure you can get that. But here's the good news. As terrifying as that might have been for you, what just happened to that fraction? It just got busted, right? No, it's really stupid, but yeah. What is 8 times 5? You know what? That number just got bigger. I don't care. We don't have to deal with the fraction anymore, right? What is 7/8 times 8? Somebody knows those 8s are going to cancel, leaving us with just 7. Some of us just typed it in our calculator. That's not a problem. Either way, it gives you what? What happened to that fraction? Right? Busted. And what's 8 times 1? So you have to make sure what you do to one side, you do to the other. You have to make sure that you distribute it across each term. Okay? But here's the good news now. That is a much easier equation to solve, isn't it?
Yeah.
Solving for x. Am I ready for inverse operations? Not yet. I got 2 x's. Can I combine them? Not across an equal sign. I can what? Isolate. Move one. Which one? Move the 6 by, if I do it to one side, on the left side I have negative 40. On the right side I have just, looks like x plus 8. We're one step away now. Oh, by the way, that was all step 1. That's simplifying. Clearing out those fractions, combining like terms, isolating the variable. Fair enough? So how do I get rid of the adding? What is negative 40 minus 8? How about negative 48 for my Canadian friends? How about? Yep. We'll talk about it. I probably
noticed they said that when I started watching Shrek.
I better be careful, actually. I have a Canadian professor right now. And
He's a real
last thing I need to do is piss him off. Oh, wait, they never get angry. I'm good. Okay.
Yeah, they do.
All right. So you got a couple choices on example 8. And so I tried to leave some space. Let me scoot this over. Because what I would do is I would clear that fraction first. There's only one fraction we have to deal with here, right?
Mm-hmm.
So how would you deal with the 1/3? What would you multiply everything by?
Could you just turn that into a decimal?
No, because that here's the issue. That decimal for this one specifically would be 0.333333 forever.
That's a repeat.
Yeah, so the minute you make it a decimal, you're rounding off and your answer will no longer be accurate. So, and you're like, well, I don't care, it's accurate enough, but this is the same math that we use to launch people into outer space.
So it has to be.
So if we don't have accuracy, we miss a planet and people die. So it's kind of a big deal. In mathematics, we need accuracy. Okay? So yes, sometimes. No, we're not rounding numbers off and saying, good luck. Okay? So what I'm going to do, though, is fine. I don't like that. Let's clear it. So I'm going to multiply everything by what? I don't really feel like I got that from him. I'm going to multiply everything by what?
3.
So here's the issue, and this is where some of you are going to like me right now. This 3 is going to multiply to the 1/3, to that group. Then it's going to multiply to the 3. And the reason why is this whole thing is grouped together. This whole thing is one group and one. So it only distributes to that 1/3, and then it goes to the next term. If that bothers you, there's another way. But it also needs to go to the 4x and the 1.
Does it go to the 2?
No, because it's already going to that group because it's going to the 1/3. If, like I said, I know that bothers people. So if you don't like this, I'm going to give you another option in a minute. Okay? But here's the good news. What is 3 times 1/3? It's gone. See how that works? That's a good deal, right? And then I'll distribute the 1. It seems a little tedious, but the 1, so I'll have x plus 2 plus 3 equals 4x minus 1. Before I finish this, I'm going to go and do option 2. If that really bothered you because you really wanted to put that 3 with the 2, what you would have to do is take the 1/3 and distribute it. So you'd have to do this. Because then what I end up with is 1/3 x plus 2/3 plus 3 equals 4x minus 1. And now I still have to multiply. I messed up. I can multiply. Guys, keep me honest. Don't have my damn liars, so keep me honest. This 3 should be a, because everything gets multiplied by 3, right? So that 3 should become a, that 4 should become a, and the 1 should become a, so everything gets multiplied by the 3. The 3 distributes across each term, okay? At this point, I got to take this whole thing and I'm going to multiply it all by, because I'm not liking that fraction. Notice what happens. 1/3 times 3 becomes 1x. 1/3 times 2/3 becomes 1/3 times 3 is still 1/3 times, or sorry, 3 times 4 is, and 3 times. Notice these two lines are now the same, aren't they? So it really doesn't matter if I know to distribute just to each group, and then I have to distribute the 1 in, or if that really bothers you, distribute that number in, and then multiply everything by the 3. It doesn't make a difference in your answer, does it? These two lines are the same. Agreed? Okay. So how would we solve it from this point? I heard combined like. This is all part of the simplifying. Okay, so I have x plus, what is 2 plus 9? Is equal to 12x minus 3. Am I done simplifying? I need to get that x on 1. So which one will you move? The smaller of them. Which is the smaller of them? So how do I move x? Subtract it away. If I do it to one side, do it to the, I'm running out of space, so I'm going to move this up here. So now I have 11 is equal to, about 11x minus 3. Now I'm ready for step 2. Why? Because now how many x's are there? Right? 1x that is being multiplied and subtracted, so we're back to the two-step equations. These are the hardest types of equations you're going to see. Yes, this kind of stuff will be on your next test. No, the entire test is not going to be made up of these. Okay? So don't get too paranoid on this. We're doing some easier ones. We're doing some harder ones. We need to be able to handle all the different elements. Fair enough? How would you solve this now? So I got 14 is equal to 11x. Divide by the, and apparently all my numbers are terrifying today, but how about 14 over 11 or 1n, oops, too far. Simmer down now. 1n 3/11. Either one of those would be fine with me. All right. Good news. That's most of the scary stuff. Sorry, I know we got a lot of notes today, but just appreciate that we don't do this every day. Okay? We are on example 9. I need to get through example 16. Oh, buddy. Good news is 9 is easy. Let's work through this. Ready? First step. The 3 distributes, giving us what? Equals, I like that dot, I'm going to make that go away, 6. That's done simplifying, right? Step 1. Step 2, undo the adding by, what's left on the left side? What's left on the right side? Did we mess up? Is that wrong? Do we start changing stuff just because the numbers look a little weird?
No.
So x is still being multiplied, right? How do I undo the multiply? By? What is 0 divided by 3? You do it in your calculator. It is x equals. Is that wrong? Can x equal 0?
Yeah, that's what it is.
Check it. Does 3 times 0 plus 2, does 3 times 2 equal 6? See, 0 is our solution this time. So don't freak out. That's going to happen sometimes. Sometimes the x's disappear. That's a whole different mess. Okay? But sometimes x equals 0. That's not a problem. Sometimes the answer is 0. All right. All right, come on. 7 more examples. Let's knock this out. Ready? Fractions. Fractions. Right? Let's clear them. I see 2 denominators, a 3 and a... What am I going to multiply both sides by? That's the way I would do this. Some of you are going to do this differently. That's fine. But this is the way I would do it. Whenever I see fractions, clear them. Bust those fractions. I know. On the left side, 6 times 4 over 3 becomes no more fraction. On the right side, 7 over 6 times 6 becomes just... How would you solve this now? By? And x equals? Whenever I see a fraction, I clear that fraction. Somebody else is going to see a fraction set equal to a fraction, and they're going to cross multiply. I don't like this, but it's not wrong. And so I'm going to take a second real quick, and I'm going to explain what you're doing when you're cross multiplying. Some people go, well, this 3 just magically jumps up to the 7. This 6 just magically jumps up to the 4, and then we get an answer. And though mathematically that is correct, mathematically there is reasoning behind this. We shouldn't just be doing this. Okay? So if that's what you're doing, I want to just make an argument right now. What you're doing is you're multiplying both sides by both the 3 and the 6. By the 3 and the 6. You don't know that that's what you're doing, but that's what you're doing. So on the left side, what would happen with the 3 on the top and a 3 on the bottom? They would cancel. On the right side, what would happen with a 6 on the top and a 6 on the bottom? Notice, where did the 3 end up? Up with the... Where did the 6 end up? Up with the 4. So that is technically cross multiplying, but you shouldn't just do that, because I'm telling you, that's where people start just doing other things with fractions and getting themselves in trouble. So if you want to cross multiply, just multiply both sides by both denominators, both the 3 and the 6. And I don't, sorry about that, I don't like this as much. This won't always happen, but in this situation, because you end up dealing with an x and a whole mess that's bigger when you don't just deal with the least common denominator. That's not always true, but this is one where it is. So how would you solve for x? By? But this is 21 over 24. Is that the same answer? You would just have to simplify and know that 21 and 24 are both divisible by to give us 7 over 8. So to me,
It's just more work.
I get how to do it. I can even justify it, but I would just clear the fractions. And if the fractions don't have anything in common, then yeah, you'll just multiply them by each other. But I would use that. That's a more logical approach for me. Okay? Look at this next one. Freaking x in the denominator, right? I don't care. Our denominator has an x and a 3. They don't have anything in common. So I'm going to multiply both sides by both parts, the 3 and the, both the 3 and the x. And if I do it to one side, so what can cancel on the left side? The x over the x become a 1. And so I'm just left with, what's 3 times 2? On the right side, I have what cancels? leaving me with negative 5x. Someone right now was like, I would have just cross-multiplied that. You're right, it would have given you the same thing this time. Okay? But this is what you really would be doing. So pros and cons. Okay? And I'm not here to argue with you about that. So what would our last step be? By? Thank you so much for not saying adding. That makes me sad when I hear that from people. You'll know if you do that on the test because I'll walk by and I'll see you do that, and there'll just be a tear that runs down my face. It makes me so sad. So don't do that, please. Also, do not leave x as 6 over negative 5. That won't be acceptable. Where should that negative go? Either negative 6 over 5 or negative, and then the fraction 6 over 5. Or negative 1 and 1/5. Do not leave the negative in the denominator. Mathematically, it's the same stinking answer. But remember, when we're dealing with mathematics and we have to give things common denominators, do you want a negative in the denominator? It's complicated. So stylistically, we either put it on the top or on the side. Okay? Oh, we're flying now. We got like only a few more options. We're almost done. Can I scoot this down? Some of you wished you wouldn't have said yeah. You're like, oh my gosh, it's fractions. Run away. Okay. Look at all the denominators. Can you find a number that those could all become? There you go. So and then let's be clear. I don't want to make them all the same. I'd rather get rid of the fractions. So if the least common denominator is 4, what am I going to do with that 4? This whole side gets multiplied by 4. This whole side gets multiplied by 4. Every term gets multiplied by 4. Watch, this is where the magic happens. What's 4 times 1/4? Just x. 1x or 1x, right? What is 4 times 4? What is 4 times 3/2? Fraction went away, didn't it? What is 3/4 times 4? In one step, all those fractions clear out. Right? Now we're back to the easy stuff. Can I use inverse operations yet? I'll give you a hint. No. We're now done simplifying. Can't solve for x when there's 2 x's. Can I combine them? Please tell me no, they're not on the same side. How would you isolate them? Which one's smaller? How would you move a 1x? Do it to one side? What is 6 minus 1? You see how all these skills build off the previous on real numbers? So, and I think most of you have been doing pretty well with that, but you need to know how to keep track of your real numbers. And I'm not saying you have to know all the rules for when they combine and cancel and all that. You have the technology, but you need to have some good foundational understanding. Okay? Now we're ready for inverse operations. I undo adding by. I got negative 19 is equal to 5x. I undo multiplying by. And I've got friggin' 19 over 5. Ew. Or about 3 4/5. I'm going to let you guys choose on this one. Do you want me to distribute, then clear the fractions, or do you want me to clear the fractions, then distribute? Do what first? I heard distribute first. I find that if you know how to do this, if you do it my way, you're going to end up with, well, if you do it my way, and you multiply everything by, what is the LCD? If you do it my way, you're going to end up with 5 times x plus 5 minus 9 times x plus 2 equal to 1. So if you want to try it that way, go ahead. But I think most people that it's just harder to keep track of, you might want to just distribute this mess and get 1/3 times x plus 5/3 minus 3/5 x minus 6/5 equal to 1, and then multiply everything by the, what's going to clear out those fractions? Multiply everything by the 15. That's the feeling I'm getting from most of you, is that this would be the method you prefer, because then it goes across each term, and we don't have to keep track of groups and all that weirdness. Do you know what 15 times 1/3 is off the top of your head? You don't have to. You can put it in there, hit enter. I heard 5x. Do you know what 15 times 5/3 is? Do you know what 15 times 3/5 is? 15 times negative 6/5. Is that right? What is 15 times 1? Don't leave it as a 1, right? It has to multiply across all the terms to both sides. Whew. Ready to solve this? What do I need to do? Get more space for one. There's combine like terms only when they're on the same side. What's 5 minus 9? What is 25 minus 18? 2 steps. That's all step 1. Step 2 says, now what? Subtract the 7. So that negative 4x is equal to 8. Thank you. We don't add. That's utter nonsense. And thank you for dividing by the negative. A lot of people miss that. So that x is equal to? Awesome. Could I check it? Gosh, that'd be a mess if you wanted to check it. But if you want to, you can. It will clean out and it will turn into 1. But it's your choice. Okay? What if it's decimals?
It's 0.1 what?
0.1 OT. Okay, ready? Plus 0.05 times 20 minus t times 0.09 times 20. I'm going to encourage you, based on the feeling that I got from most of you, that I would distribute this first. Is that okay? So 0.1t plus, what is 20 times 0.05? Is it just 10? I don't think so. It's all right. I almost believed you for a second. Oh, that still wouldn't be 10, but way to back yourself up there. What is what's 0.05 times 20? It's 1. It's okay. Yeah, now he's all confident. It's 1. Yeah. 0.5 times negative 1 would be negative. And on the right side, what is 0.09 times 20? Somebody tell me 1 point what? Dang it, I hate when it does that. 1 point what?
8.
There you go. You have 2 options. If you're terrified of decimals, we can make these all whole numbers by multiplying by powers of 10. Multiply by 10, multiply by 100, multiply by 1,000, multiply by a power of 10 to make them all whole numbers. Nothing wrong with that. Or you could solve this with just decimals. You have technology in your hand. You could leave the decimals, combine like terms, subtract, divide, you get the same answer. What I think most of you are going to do is take all of this and multiply it by what? I need this decimal to move once, but I need this one to move twice. So I'm going to argue multiplying by 10 won't do it. That makes sense what I'm saying? If I multiply by 10, the decimal will move once. I need it to move twice. So I'm going to multiply it by what? That means that's going to multiply across everything. Ready for this? 100 times 0.1. 100 times 1. 100 times negative 0.05 equals 100 times 1.8. Could you solve it from that? No more decimals, right? So I heard combine like terms.
Are you going to show us if you do decimal?
Yeah. Okay. Now what? And last? And t is equal to 16. Very good. What if I just left it as decimals? Would that change the rules? What if I just left it as could I have still combined like terms? Yeah. And I don't have to be all, you have technology in your hand, don't you? 0.1 minus 0.05 is? Now I would do inverse operations. Undoing the adding, I would what? And last but not least, to undo the multiplying, I would. And what is 0.8 divided by 0.05? It's the same freaking answer. So if you don't like the decimals, learn to get rid of them. If you're like, why am I afraid of decimals? I have technology. Then use the technology. Either way, you get the same answer. Does that make sense? And I have some people that they're like, I'm going to make it whole numbers, and they deal with the big numbers, and we're good with that. I have other people that are like, I don't like messing and adding the step. I'll just do it all in my calculator. Your choice. Fair enough?
I have a question.
Yes. No, you have to divide it. Yeah, and if it were, well, being that all these are decimals, if our answer even was a fraction, they would want the answer as a decimal. Yeah. All right. Two more things, and we basically covered about probably 35 to 40% of the content of what's going to be on the next section. So it gives you a kind of start. That's why I told you that you should have the pi section on real numbers done. Okay? That being said, this is just a brief introduction into word questions, just to give you oh yeah. Just to get some of the words out of the way. Two numbers have a... Yeah. You got time. What is the key word on the first sentence of example 15? What does sum mean? We have two things we don't know. They said call the first one X. What could we call the next one? We don't know what it's called, right? So we could call it what? Yeah, whatever we want. So I'm going to do X plus whatever we want. Give it another letter. How about X plus? J. Why not? Okay. and they sum or they add to what? If one of them is x, find an expression for the other number. Basically, that means solve for whatever our other was. Solve for, in this situation, j. Could you solve that for j?
No.
Can you get that j by itself?
Can you subtract that?
If you subtract the x. If I do it to one side, so what would j equal? Not 23 times x. That'd be 23 times x. Those are not like terms. So 23. Or if you want to get more complicated, you could put the x first. But I actually like this better this time. Because here's what the logic, here's what you just said.
That's it?
That's it. We're going to do more with this later on, but yeah, just getting used to some of the words. But here's what we just said. If two numbers add to 23, what if the first number was 5? What would the second number be? Wouldn't it be 23 minus 5 is 18? Right? What if the first number was 10? Then 23 minus 10 would be 13. So you could make, this is an equation where we could get answers really quickly. We will be solving equations where we get numerical answers, but we're going to be getting to the point where we're going to be solving equations where our answer has variables in it. And guess what? The process doesn't change. We still said we're solving for j, and we undid adding by subtracting. All right. One more. Two numbers have a product of 24. What does product mean? Good. So we're going to multiply x times some other number. What are we going to call the other number? You like j still? All right. So we got xj. And they're multiplying to give us what? Could you write an expression? Could you solve for the other number? How would you solve for j? We would undo multiplying by so that j would equal. See, now what could I do? What if the first number is 3? Could I divide that and say the second number is 8? Right? What if the first number is 4? Could I divide that and find that the second number is 6? This is a quick expression. What else does this do for me? What if the first number was 0.5? Ruh-roh. Scooby snack, I know. You could do 24 divided by 0.5 is 48. It would still give us other answers, even when it's easy, when it's hard. But this is just an idea to show you that we're going to be translating a lot of your word questions are just translating words. And in the future, we're going to be solving equations that have just letters. Is that okay? All right. Thank you, guys.